Hey guys, it's Mr. Gron, coming to you from my garage this time instead of my basement because my wife and my son are watching a movie down there. And the reason I'm making this video today, one would be for supplemental stuff on Canvas. Two, the little guy threw up a couple hours ago, so I might be homesick with or home with a sick boy tomorrow. So I'm coming to you from the garage. If you don't believe me, here's some garage stuff. There's my snowblower, some of my wife's pottery stuff, deep freeze, taxidermy, garage fridge with a crappy old TV and stereo on it, messy tool bench, wife's pottery because this is also her studio when my truck isn't in here, crappy truck that I'm about to sell to a junkyard, bikes, that sort of stuff, table saw covered in fishing stuff and whatnot. Yeah, it's a garage. Alright, so 8-8 day 2. Here's our objectives today. So radical equations, right? We're solving radical equations with rational exponents. So instead of being a square root symbol, it's going to be raised to the 1/2 or 1/3 power, or whatever. And then solving radical equations resulting in x squared. Yesterday in class we went over ones where it resulted in a linear equation where after we did some stuff it basically became like 3x plus 1 equals 5 and we solved for x and that sort of thing. So these ones are going to have two solutions and one of them is going to be extraneous. So we'll go over that in a little bit. Alright, so our first example, we're going to get the radical or rational exponent example out of the way because that's really the same thing as we did yesterday. So something like this. Let's say we've got in parentheses 3x minus 1 to the 1/5 power is equal to 2. How do I solve that? Well, a couple ways that we can do it. One way would be if we have it raised to the 1/5 power. Hopefully we remember that this is the same as the 5th root of 3x minus 1. And then how do I cancel out that 5th root? I have to raise it to the 5th power. So raise this to the 5th, raise 2 to the 5th, and our radical raised to the 5th, it just cancels out the radical, and this becomes 3x minus 1. 2 to the 5th power, 2, 4, 8, 16, 32. Look at that. And then just solving from there. Add 1 to both sides. 3x equals 33. Divide both sides by 3, and x equals 11. Odd root function, not going to be an extraneous solution, so I really don't have to check this one. If it were an even root function, you'd want to check it to make sure it's not extraneous. Alright. So, long story longer, if it's a fraction as an exponent, change it to a radical, and then just apply the proper power. Okay. Next example. Now we get serious. I might need the whole stinking board for this one. Okay. This is going to be the square root of x plus 18 equals x minus 2. Now, same rule 1 applies as yesterday, and I'm going to put the rules for this on Canvas, kind of the steps to go through. However, I want to isolate the radical. Now this one's already isolated, so I can skip to the next step, which is squaring both sides. So, let's get ready to square stuff. Now, on this side, the squaring just gets rid of the exponent, or not the exponent, the radical symbol, the square root symbol. But over here, now I got to do a little bit of foiling or use the box method. X minus 2 squared is x minus 2 times x minus 2, which is going to be, when I FOIL these out, that will be x squared minus 2x minus another 2x plus 4. And on my other side here, it's just x plus 18. Okay? Now, Last unit we did some of this stuff where we had problems that resulted in quadratics and solving them by factoring, right? And so what we needed to do was get everything into standard form on one side of the equation and have it be 0 on the other side of the equation. I'll move my big head so you can see what we're doing. Probably want to combine like terms over here first. So we'll make that x plus 18 equals x squared minus 4x plus 4. And now I can get all of this stuff over to here by subtracting. So minus x minus 18 minus x minus 18. That'll cancel that crap out. And we get 0 on this side is equal to x squared minus 5x minus 14. 4 minus x is negative 5x. 4 minus 18 is negative 14. Now this is a quadratic that we can solve by factoring, and that's pretty much all the ones that we're going to be doing in this section. This is a salt and pepper factor, right? So 0 equals my factors that multiply to a negative 14 but add to a negative 5 are going to be x minus 7 and x plus 2. Change the signs in here to solve for x. This is going to be x equals positive 7 for the x minus 7 and negative 2 for the x plus 2. Now, we do need to check these to make sure that they actually work. Plugging them back into my original equation, we'll start with 7. So x equals 7. We've got the square root of 7 plus 18 equals 7 minus 2. 7 plus 18, that's square root of 25 equals 5. I think that's true if my Thief River Falls math is correct. So that's good. That's a good equation, or a good solution. Now let's try negative 2. So for x equals negative 2, we've got negative 2 plus 18 equals negative 2 minus 2. And again, I'm just plugging this in back into the original equation, right? I'm just changing x to negative 2. Alright, so this ends up being the square root of negative 2 plus 18 is 16 equals negative 2 minus 2 is negative 4. That is not true. So this would result in 4 equals negative 4, which is an extraneous solution, so that one does not work. Therefore, my solution is x equals 7, and x equals negative 2 is extraneous, is our extraneous solution. So, there you have it. That's one example. Let's do one more. Feel free to pause and give it a shot on your own at any time, and hopefully this is helpful. So let's take a look. Okay, next example. Now, we're going to get a little crazy with this one. We're going to say that this is the square root of negative 3x plus 33 plus x equals 5. Now, before you start it on your own and pause it and start it on your own, you might want to wait for this first step just to be safe. So, the way I'm going to start this is this. I still need to isolate x to begin with here. Or not isolate x, excuse me. I need to isolate my radical. So what that means is going to be subtracting this x from both sides. And I'll cancel out. Square root of negative 3x plus 33 is equal to 5 minus x, something like that. Not in standard form right here, but it's fine. Alright, now I've got it isolated. I can square both sides. My radical will disappear magically, almost magically. And then over here I still need to FOIL this out, actually. I'm going to FOIL this out first. Alright, so on this side, 5 times 5 is 25. 5 times negative x, negative 5x. Negative x times 5 minus 5x. And negative x is plus x squared. then on the other side, negative 3x plus 33. Okay, with me so far? Good. Probably want to combine like terms on this side next. Negative 3x plus 33 equals. And I'm going to get this into standard form at the same time. So I'm going to start with the x squared, then negative 5 and negative 5x is negative 10x, and a plus 25. So I simplified it and put it into standard form because, you know, I'm like that. Okay, setting this side equal to 0 now. I need to add this 3x to both sides, and I need to subtract this 33 from both sides. That's going to cancel everything on this side, so it's equal to 0. And I'll get 0 equals x squared, negative 10 plus 3x minus 7x, and 25 minus 33 is minus 8. I'm pretty sure if we do a salt and pepper factor there, that's going to be x minus 8 and x plus 1. That's going to give me solutions of x equals positive 8 for the x minus 8 and negative 1 for the x plus 1. Now I need to check those two solutions back in my original equation. Alright, let's see how she works. So for the x equals 8, we've got the square root of negative 3 times 8 plus 33 plus 8 on the outside equals 5. This will become the square root of negative 24 plus 33 plus 8 equals 5. Negative 4 plus 33, that is the square root of 9 plus 8 equals 5. I'm pretty sure the square root of 9 is 3, and if I add 8, it's not going to be 5. It would have to be negative 3 plus 8 equal 5, so this is not a good solution. That's going to be extraneous. Now I'll try negative 1. So for x equals negative 1, we've got negative 3 times negative 1 plus 33 plus negative 1 equals 5. Again, just going back to that original equation, plugging in negative 1 for the two x's. That'll be negative 3 times negative 1 is 3 plus 33 plus a negative 1 is the same as minus 1 equals 5. 33 plus 3, square root of 36 minus 1 equals 5. 36, the square root is 6 minus 1 equals 5. That's a good solution. X minus equals negative 1 is our solution, and x equals 8 is our extraneous solution. So there you have it.